So we want to be able to find the exact values of the trig functions using a point on the circle. So if we have a point on the circle, -1/2 square root of 3 over 2, and it would be approximately here, it'd be in the second quadrant, then can you define all of the trig values for sine t, for that real number t? Remember, t is a real number that stands for the length of that arc because it came from taking a real number on a number line and wrapping that distance around to see what point on the circle would correspond to that point t. So we know that the sine is the y-coordinate, so sine t would simply be the square root of 3 over 2. And notice this is a unit circle because things would be just a little bit different if it wasn't a unit circle. So sine t is the square root of 3 over 2. Cosine t is the x-coordinate, so that's simply -1/2. And be sure you don't just write sine equals cosine equals. The sine and cosines are functions. Well, all the trig functions are functions. They have to have an argument. You can't just say sine equals cosine equals. It has to be sine of something, of some angle. So sine cosine, the next one is tangent. And we know that tangent is sine over cosine, which is y over x if we're talking in terms of the ordered pairs. So that would be the square root of 3 over 2 divided by -1/2, and the 2's cancel and we have negative square root of 3. So sine, cosine, and tangent, and then we've got cosecant, which is the reciprocal of the sine, and it's also 1 over y. Either way, the reciprocal of sine, we can just write 2 over the square root of 3. If we wrote 1 over y, then it would be 1 over the square root of 3 over 2, which is also 2 over the square root of 3. And then technically we're not supposed to leave radicals in the denominator of a fraction, so we would rationalize that fraction by multiplying by the square root of 3 over the square root of 3, which is just multiplying by 1. So we have 2 times the square root of 3 over 3, and that's how we would leave the final answer for that. Then we have secant, which is the reciprocal of cosine. So secant t is the reciprocal of cosine. The reciprocal of -1/2 is -2. Or we could say it is 1 over x, so it would be 1 over -1/2, which means 1 divided by -1/2, which is also going to give you -2. And then we have the cotangent, which is x over y, or it's also the reciprocal of tangent. Doing the reciprocal functions is probably going to be easier, especially when you're dealing with fractions. So the reciprocal of negative square root of 3 is 1 over negative square root of 3. And again, we need to rationalize. So we multiply by the square root of 3 over the square root of 3, and we have the square root of 3 over 3, and that was negative. And that's how we should leave our answer. If we use the x over y, then we would have the cotangent t equals x over y, and that would be -1/2 divided by square root of 3 over 2. It's a complex fraction, and the 2's are going to cancel, and so we have -1 over square root of 3. Same thing we had over here, and then we rationalized it. So that's how you, once you find the point that is paired with that real number t, then you've got the x and the y, and you can figure all 6 trig functions from that x and y value. Now, if theta is equal to t radians, then the 6 trig functions of the angle theta are defined as follows. The sine of theta is equal to the sine of t, so it doesn't really matter whether you're talking about the angle in degrees or in radians. That would be like saying the sine of 90 degrees is equal to the sine of pi over 2 radians. And the same for all the other 6 trig functions.